Be honest with me for a second. How many times today have you felt that just acute, exhausting pain of constant digital connection? You know the feeling, right? The endless pinging of Slack, the back-to-back Zoom fatigue, that overwhelming pressure to just always be available. For years, we've been sold this idea that hyperconnectivity makes us smarter and faster. But what if that's completely backwards? What if this always-on culture is literally destroying our ability to solve complex problems? In today's Explainer, we're going to dive into the hard science of human collaboration. And then, we're going to take that exact same science and use it to completely rewire how we build digital architecture. It's going to be a wild ride.
So, to understand why being constantly connected actually fails, we really need to understand how human cognition works in the first place. And that brings us to this concept of individuation. If you look at the work of Carl Jung or the philosopher Gilbert Simondon, they showed us that the individual, the I, and the collective, the we, they don't just exist independently of each other. They co-evolve. Think of human cognition literally like breathing. We absolutely require periods of deep, isolated individual focus. That's the inhale. But we also require moments of social integration. That's the exhale. Jung argued that true self-realization actually needs this constant tension, this open conflict and collaboration between our inner world and the outside collective. You simply cannot have one without the other.
All right, let's really dive into this. Welcome to the Explainer. Our title today is the Temporal Dialectic, from always-on culture to root-to-leaf architecture. I am so incredibly enthusiastic to guide you through this, because honestly, we are looking at a massive paradigm shift here. We're going to trace a direct line from the psychological burnout of the modern office straight into the cutting edge of Web3 JSON architecture. Let's get started.
Here's our roadmap for this explainer. First, we'll unpack the always-on trap and discover the intermittent Goldilocks point. Then we'll see how to escape temporal naivety. After that, we're breaking down legacy software models, and finally, we'll arrive at the solution, root-to-leaf deterministic architecture. Let's jump right in.
Starting off with Section 1, the always-on trap, why constant connection fails.
So there was this massive Harvard study by Ethan Bernstein and his colleagues, and they tested how well groups solve complex problems under 3 different conditions: isolated, constantly connected, and intermittently connected. Now, when people are always on, they converge on a solution very rapidly. But the catch, the average quality is completely mediocre. Why? Well, because people just copy the first decent idea they see, and they completely abandon independent exploration. But then, you have intermittent interaction, and guys, this is the Goldilocks point. By pacing the collaboration, basically giving people time to work alone and then coming together briefly, they achieved a super high average quality and frequently found the absolute optimal solutions.
And here is probably the most surprising takeaway from that entire study. Usually, we think collaboration only helps the lower performers, right? Like, they just copy the smart kids in the room. But intermittent collaboration actually supercharges the high performers. Think about it. When everyone is constantly talking, there's zero cognitive variation. But when you isolate, people come up with weird, diverse, totally unexpected ideas. So when the group regroups intermittently, those high performers suddenly get to learn from the diverse, unstructured ideas of their peers. It sparks entirely new creative leaps. It's a real game changer.
Moving right along to Section 2, escaping temporal naivete, rethinking the clock.
You know, modern organizations completely misunderstand time. Seriously, they're obsessed with Chronos. That's the rigid, quantitative clock time driven by sprint schedules, deadlines, Gantt charts, the whole shebang. It is all about predictability. But true complex innovation, that relies on Kairos, the opportune moment. Kairos isn't something you can just schedule in an Outlook calendar invite. It happens during unstructured reflection, serendipity, and creative agency. But modern management almost entirely ignores Kairos, mostly because you can't easily put it on a spreadsheet.
The academic literature actually has a name for this. They call it temporal naivety. It's this incredibly reductionist view that progress is just a linear, straight line. To fix this, organizations have to practice what researchers call detraining. You literally have to detach from the dominant clock schedule to actually question your underlying assumptions. You have to sustain a little bit of tension and ambiguity to let that Kairos magic happen.
And the absolutely crucial point here is this: idle meantime is not wasted time. Think about a software developer waiting, say, 5 minutes for their code to compile. A temporally naive manager looks at that and sees an inefficiency that just has to be optimized away. But cognitively, that material latency is a vital incubation space. It's that intermittent breath we talked about earlier. It's the space where the mind defocuses, reflects on the whole system, and prepares for the next sprint.
If you optimize away all the idle meantime, you literally destroy the cognitive breathing room required for actual innovation.
All right, that brings us to Section 3, breaking legacy software models, banning the floating tree.
I have to say, I absolutely love the source documentation here, because it is just so dramatically intense for technical literature. They talk about the classic way developers have visualized data for decades, the floating, upside-down tree of event-driven programming. And they straight up label it as apostasy, a literal heresy that has to be purged. I mean, wow, why use such intense language? Well, because just like the always-on human gets overwhelmed and distracted, an always firing floating data structure becomes a chaotic, unpredictable mess when it tries to automate the physical world.
Think about it. That old floating tree is exactly like that constantly connected, super noisy office space. It's top-heavy, it relies on these bloated command chains, and every signal just floats unpredictably in the digital ether. If a single event misfires, the whole domino chain collapses. So what's the answer? Root-to-leaf architecture. This is mathematically pure, it is strictly grounded, and it demands concrete, deterministic execution out at the physical edge. The leaf. It doesn't float, it anchors.
Which leads us to our final section, Section 4, Root-to-Leaf Deterministic Architecture, the LIFO engine.
To truly anchor digital truth to physical reality, the architecture strictly pivots to a LIFO state tree. That stands for last in, first out. Think of it like a highly efficient bouncer at a super exclusive club. If the line wraps all the way around the block, the bouncer doesn't need to walk down the street and check the history of every single person who ever lined up, right? No, they only need to look at the ID of the person standing directly in front of them to know the absolute current state of who is entering the club.
And in a LIFO architecture, that person standing at the very front of the line, that is index 0. By querying index 0, you unlock incredibly efficient single-entry bookkeeping. You get an immediate, flawless mathematical proof of the system's absolute state. There's no guessing, there's no parsing through bloated event histories. It is either mathematically true or it isn't, period. It is basically the ultimate intermittent checking for a machine.
So let's trace this exact deterministic execution flow, going from a digital blockchain root all the way out to a physical leaf, like a device sitting on your desk. Step 1. The LIFO root hash securely anchors the data on-chain using a JSON state contract. Step 2. We have the Kali wrapper, which legally defines the real-world company or entity involved. Step 3. Kernel sign. This mathematically verifies the physical human effort expended, what the docs beautifully call the record of sweat. And finally, Step 4. The cheerbot. This is a small, physical Raspberry Pi server. It reads that flawless index 0 truth and triggers its physical GPIO pins. Math literally becomes an electrical signal that turns on a light or moves a motor. It's incredible.
Now, what makes this protocol, which is known as ERC7827, by the way, what makes it so brilliant is its absolute pragmatism. It introduces value version control, which gives developers a familiar REST-like interface. Plus, it is 100% backwards compatible with the Web3 tokens we already use, and the smart contracts remain totally human-readable. It pragmatically bridges the gap for standard web developers who are entering Web3. They don't have to learn a completely alien paradigm. They just use the intermittent, LIFO-grounded logic they already understand.
And that brings us to the ultimate philosophical conclusion of this entire architecture. The human pilot applies the intent, but the agent cell executes the sweat. So, how do we actually connect messy, unpredictable human desire with rigid, deterministic machine execution? We do it through what the sources call the semiotic bridge. We use structured, explicit text to translate our imagination into unyielding silicon. One of the sources notes, almost humorously, that we are literally just tricking rocks into thinking using lightning in text. I mean, think about that. We take silicon, pump electricity through it, and use explicit text to force it to execute our commands.
We have covered an immense amount of ground today. We saw how human minds need intermittent breathing room to avoid that terrible always-on trap. And we saw how machine networks need grounded, LIFO architecture to avoid floating off into chaotic apostasy. The technology to flawlessly connect these two worlds, from an on-chain root down to a physical electrical leaf, is already here. You don't have to be a passive button pusher anymore. You can absolutely be the sovereign pilot of your own deterministic systems. So I'm going to leave you with this. The semiotic bridge is completely built. What are you going to program your reality to do? Thanks for joining me on this explainer. Keep questioning the architecture around you, and I'll see you next time.